All right, so we're going to take a look at a couple of titration calculations. This first one just has to do with the finding the equivalence point. Regardless of whether you're titrating a strong acid and a strong base or a weak acid, weak base, all that matters when you're finding equivalence point is the number of H pluses versus number of hydroxides. So if it's a 1-to-1 ratio in the acid and the base, then we can just use the very simple equation, which looks like our dilution equation, M1, and really it's like the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. So again, the only exception to this would be if I'm using a diprotic acid, I would need to factor in that equivalent mass, or that idea of, that there's double the hydrogens that are produced per formula unit. It does not matter if it's strong or weak. For a given concentration of acid and base, the equivalence point is going to be the same. So if I had 0.1 molar of hydrochloric acid that I was titrating with sodium hydroxide, or 0.1 molar acetic acid I was titrating with sodium hydroxide, doesn't matter. Both of those would actually have the same equivalence point with the same concentration. Again, the pH at the equivalence point, that is what's going to be different because of the nature of the weak versus strong acid. But not the equivalence point itself and the number of milliliters needed to get there of our base. Okay, so for this problem, this is actually one of your homework problems. How many milliliters of 0.105 molar HCl are needed to titrate 45 milliliters of sodium hydroxide to the equivalence point? So again, this is our equation. This is a 1-to-1 relationship. And so my volume of the base, again, if I'm putting this in milliliters, then as long as I do the same thing for both volumes, it doesn't matter if I leave it in milliliters, even though molarity technically is per liter. And the concentration of sodium hydroxide is 0.0950. I forgot to write that down, 0.0950. So that's what goes here, 0.0950. And again, how many? So I'm looking for the volume, and 0.105, and technically, again, these are molarities, so that molarity is going to cancel out, and the volume of acid needed, I'm just going to rearrange and solve, so the 0.095 times 45 divided by 0.105, and that would give you 40.7 milliliters of HCl are going to be needed. So there you go, there's finding your equivalence point.